In this video, we're looking at the basics of common logs and natural logs. Again, very much like the radical, the square root is a function that we don't include the 2 under over top of that so-called house thing, the radicand. In terms of a log function, again, there was one that we briefly referenced in the beginning of these lectures, is the natural log. The natural log is log base e of some function x. This natural log is ln of x. Please make sure that you understand that this is the same exact thing. They're just different notations. It's very much like I have $1 over here and I have 4 quarters over here. In most cases, this is the notation that any textbook will probably use in reference to the natural log. So you have to understand that ln, again standing for the logarithmic of the natural form of x, is the log base e of x. Now a common log, on the other hand, is if we were to just simply drop the base. But the dropping of the base, the only one we're allowed to do this with, is log base 10. So if we look at log base 10 and we don't write any base, then the log without a base is log base 10. So these are your 2 specific rules in terms of your special forms of logs, and we just have to make sure that we understand what they are saying. So for instance, if I had over here, I'm going to go ahead and create myself a table. If I had the natural log of 1, we have to understand that this is the same thing as log base e of 1. And if I wanted to evaluate what this is, what power of e will give me 1, well, that rule is always the same as 0. Again, if the inside is 1, we're going to have 0. So this holds true over here. If I have log of just 1, well, log base 10 of 1, again, that's what you have to understand. That's if there's no base there, it's log base 10. What power of 10 will give me 1? And that's going to be 0. I can do this for other examples. Natural log of e, for instance, is again log base e of e. What power of e, if I don't have a base here and it's ln, what power of e gives me e? That's going to be 1. Over here I could do log base 10 of 10 equals to 1. This holds true for every single one of the basic logarithmic properties. So it's important for us to just remember that if I see log without a base, it's log base 10. If I see ln, it's a natural log of base e. Again, that e being 2.718, so on and so forth. It's very much like that of pi, just a slightly different number. In that case, it covers all the basic examples and ideas for the rules of logarithmic functions. Let's look at a application example in terms of a specific function. So let's reference that this function here, f of x equals 29 plus 48.8 log of x plus 1. So the first thing we have to understand with this particular example is that that's log base 10. Again, if we don't write the base there, if there's no base there, then it's base 10. If I fail to write the base, say the base was supposed to be 4, and I don't write the base here such that it was supposed to be 4, well then this whole problem has changed and it's not the same logarithmic function. So if there's a 4 there, you have to make sure you write the 4. The only time you're allowed to leave the base out is when it's log base 10. And again, in most notational textbooks or anything that you'll see, they won't write this, they will write this. If you leave the base out, it's base 10. So for the example, let's go ahead and read this. The percentage of adult height attained by a boy who is x years old can be modeled by this function. So keep in mind that the log functions, remember, if they look anything like a log function, they should look something like this. You'll notice here that it's basically non-existent. They have no height until they get to a certain age, and then it tends to taper off. If you look at a log function in a calculator, yeah, it's going to increase continuously, but it does taper off and doesn't increase nearly as fast as, say, maybe an exponential function would. But where x represents the boy's age. So that means that in this problem, this is the age, and f of x, one more time, the percentage of adult height attained by a boy. So f of x represents the percentage. This is the percentage of the height. Meaning that if they've reached 5 feet tall, that could be, say, 80 to 90% of their overall height. They could continue to get taller. It's also possible that, say, they reach 6 feet tall, that they're done reaching and they've reached 100% of their height. So the question then retained by this problem says, approximately what percentage of his adult height has a boy attained by age 8? So again, the goal is what percentage or how how tall in comparison to how tall he's going to be is this particular individual at age 8. So our age 8 is going to be us plugging in 8 for x. That's it. That's all we got to do. We just have to evaluate this function. I want f of 8. What is that going to be? Well, 29 plus 48.8 log of 8 plus 1. So that's going to be 9. And then if I evaluate log base 10 of 9, now you can't really evaluate these functions unless they're a value you know. So let me go ahead and ask the question that I've asked in previous videos. What power of 10 will give me 9? That's the question you want to ask. Again, log base 10 of 9, if I'm just going to convert this over, what power of 10 will give me 9? I shouldn't probably use x. Let me go ahead and use just a b there. B is probably a bad notation, but I'm going to use a letter other than x and y, because those are technically already in this problem. So I want to know exactly what power of 10 will end up giving me 9. Now, because this value is not something that we know off the top of our heads, we're going to have to use a calculator. Now, in a calculator, you're going to basically type exactly what you see in here, making sure that you use the appropriate button. There are 2 different log buttons you're going to have on your calculator, depending on what calculator you have. If you have a TI-84, normally you'll see an LOG button that stands for log, and that stands for log base 10 because there's no base. Or you'll see an LN button. That LN button stands for, again, log base E. So in this case right here, if we were to go ahead and type this stuff into a calculator, we would type in 29 plus 48.8 times log of 9. In doing so, by evaluating this, we would get approximately a value of 76. Again, typing that appropriate into a calculator, that's what we would get to. To end this problem, we would legitimately say that this 8-year-old boy has reached 76% of his total height. And that's how we would actually evaluate these types of problems. In most cases, for us to evaluate these problems, we would use a calculator. But let's just say, for instance, if I didn't have a calculator, what kind of question could this particular problem ask? Well, it could ask instead f of 9, because f of 9 is something we could potentially evaluate. You'll notice by if we use f of 9, I'm going to end up with a value that looks like log base 10 of, well, when I plug in 9 to this function up here, 9 plus 1 is 10. So it's log base 10 of 10. And remember, log base 10, what power of 10 will give me 10? The answer is 1. So this will give me 29 plus 48.8, which is again closer to 77.8, or approximately 78%. So you'll notice that over the 1 year age gap from age 8 to age 9, he's gained approximately 2% of his height. Keep in mind that this, again, is not going to be a stagnant value that is always increasing by 2% every year, but because the logarithmic function, the way it behaves, it'll probably increase a little bit more rapidly as he gets a little bit older, and then it'll slowly taper off to nearly nothing. But that's how you, again, evaluate basic log functions. We'll talk about more how to work with these functional log problems and how they span into more complicated examples as we build more and more on top of the concept of a log function.